It's important for veterinary professionals and other professionals to understand how breakthrough works. We all know that protein is broken down in the gut into amino acids, and there are some key amino acids that are important as far as how breakthrough works. We're talking about tyrosine, which is a non-essential amino acid, i.e. it does not have to be taken in the diet, and tryptophan, which is an essential amino acid. Now, these two amino acids are taken across the blood-brain barrier and converted into, for tryptophan, serotonin, and for tyrosine into noradrenaline and dopamine. Obviously, we require all of these three neurotransmitters to ensure that the balance of the brain is maintained. However, there are some other amino acids which compete for the active transport system from the blood to the brain across the blood-brain barrier. And these are valine, leucine and isoleucine. So we have 5 precursors, 5 amino acids trying to get across the same transport system. Very interestingly, in response to insulin secretion, valine, leucine and isoleucine are diverted to skeletal muscle. So if we provide a carbohydrate load, insulin in response to the carbohydrate load will ensure that tryptophan and tyrosine are the only amino acids that are competing for that active transport system. So breakthrough is working on that principle. The carbohydrate is a slow-release carbohydrate which ensures that the time that valine, leucine and isoleucine are going to be diverted is critically at the right time when they are being absorbed into the bloodstream. Any earlier, it wouldn't have any effect. So we've now got tyrosine going across the blood-brain barrier and tryptophan. Interestingly also, tryptophan is a very low affinity amino acid. It requires vitamin B6 as part of its process to be converted into serotonin. Vitamin B6 is water soluble and therefore is not retained in the body, so sufficient amounts of vitamin B6 must be allowed to be provided in the diet. So breakthrough also does this. So now we have increased amounts of tryptophan crossing the blood-brain barrier, increased amounts of vitamin B6 to ensure that tryptophan is converted effectively into serotonin. Obviously, tyrosine is still getting across there as well because we need to be alert, which is part of noradrenaline's role. We also need to be able to learn from our actions, and that's where dopamine comes, because dopamine is the reward chemistry, but serotonin is the mood stabilizer. It doesn't just do that. In the brain, it has other effects. Serotonin enhances the production of enkephalins, which is the body's natural analgesics. And in some of our very reactive dogs, we will see that they are also very touch sensitive. So low serotonin levels, highly reactive. Low serotonin levels, highly touch sensitive. But not only does it do that, serotonin is part of the reward cascade and it disinhibits the release of dopamine, in as much that there is something stopping dopamine being released into the other parts of the brain. And if we are able to ensure that serotonin can catalyse the release of dopamine in that important area of the brain, the nucleus accumbens, then we can see that there will be improved decision making and learning ability. So breakthrough stabilises mood, modulates emotional responses, ensures that the body's natural analgesics are released, and also enables dopamine to be released and therefore improved learning and decision making.